In this video, we will discuss what are rule-based systems, right? Okay, so, rule-based systems, we've talked about various ways. They're also known as production systems. The rule-based systems are also known as production systems. They are the simplest form of artificial intelligence, simplest form. And as you will see, they're quite intuitive. It makes sense, very simplistically. A rule-based system uses rules as the knowledge representation for coding the knowledge into the system. Okay, the use for representation of coding of the knowledge into the system. Sometimes they're also called knowledge-based systems, and expert systems is a very typical name for this. During the life history of AI, expert systems have really played a big role in developing various concepts. So it's very important to know that this is a basic technology tool. The various definitions of rule-based systems depend almost entirely on the expert system that is developed that mimic the reasoning of human experts in solving knowledge-intensive problems. So rule-based system is a way of coding, as I said, of human experts' knowledge into a narrow area to make an automated system. Remember, once again, we are trying to gather how humans behave, and one of which is an expert, okay, and we're trying to get that knowledge from the expert, put it into an automated system, okay, and code it in the form of rules and come up with what we call as an expert system. It can be simply created by using a set of assertions. I've used this term before, a set of assertions or statements or facts and a set of rules that specify how to act on those set of assertions. Typically, rules are expressed as if-then statements, okay? If-then statements, also called if-then rules or production rules. So what do we mean by this? We mean that if there's something called P, if that is true, then Q is also true. There's a bit of logic there as well, okay? And which is equivalent to P and that double-headed arrow implying Q, okay? So if P is true, if P is correct, then by the application of this rule, Q is also correct or true. Very simple models can be built of these systems and adapted and applied for a large kind of problems. And as I just explained, these if-then rules are very, very simple, so very intuitive to understand. There's no programming as such involved. Of course, complex rules then interact with some functional ability as well. Computer programmers will know about that. But in general, the rules are very straightforward. So let's look at an example. If we have a fact that states that temperature is less than 0 degrees, then that temperature itself is the data, and the condition is that it must be less than 0. So rules, by the way, do not interact directly with data, but only through conditions, either singly, jointly, anding them together or oring them together, or a combination of this. Okay, that's how rules interact with data. In the figure is shown an example of the parts of a rule-based system and the interactions between them. Now here we have a table with 3 columns in it, and if you look at the table, the first column says data, the second identifies conditions, and the third column tells us about a rule. So what do we get out of this? Let's look at each column. So in the first column it says season is winter. That's a general description. And then if you keep looking downwards, you have various values of this data. Conditions are coming up in the second column. So you have something called temperature, you have wind blowing, then you have a couple of other things mentioned like road and weather. So there are four, let's say, data points: temperature, wind blowing, road, and weather. Now, for this data, the second column identifies the conditions. So if you look at temperature, the temperature has two conditions: less than 0 and greater than 0. For the wind blowing, the conditions are the wind could be blowing strongly or gently, right? The road itself, the road can be slippery or not slippery. And the weather can be cold, warm, or hot. Okay, so first of all, relate these two. Temperature can have these conditions, wind can have these conditions, road can have those two conditions, the weather has, let's say, three conditions. Now, having done that, having looked at that, let's review the rules. We only given one rule here, and on the top it says premises. By premises, it means the left hand side, the conditions, okay, of the if side of the rules. Remember, I said if then. So the if part are the premises, and this rule says that if temperature is less than 0 and if the wind blowing is strongly, that we pick up from the condition side. So temperature less than 0 and wind blowing strongly, or if the road is slippery. So if these three conditions exist in like this, temperature and wind, or the road is slippery, then the conclusion is that the weather is cold. Okay, there's no real mathematics about it. There's no nothing to be calculated as such. It's simple, intuitive, as I said. Okay, so those two conditions, they're put together, and or this condition, then the weather, that's what the rule says. So as I said, we've got two parts: the if part and the then part. There are various terms used for the left hand side, the if part. It's called the left hand side, it's called the antecedent, or a premise, or a condition. Okay, that's the if side of the rules. The then side of the rule, which is normally referred to as the right hand side, that identifies the consequence of applying this rule, the consequence, the conclusion, or the action that is performed by this rule. So if you can get this idea in your mind, I think that's what it is. That's as simple as that. There's no more, nothing to think about. Okay, so if the left hand side conditions, various names, antecedent, if that is true, then you apply the rule, the action will be the consequence or the conclusion or action. So if an antecedent, then consequence. That's as simple. Okay, now let's look at a couple of other examples. If the season is winter, okay, that's the antecedent side. If the season is winter, then it is cold. That's the consequent, and we all know about it. Rules can be classified in various ways. I didn't want to really go deep into it, just to give you an idea. There are several ways to classify the rules in larger systems. The rules can be classified in terms of the function of the rules, or the behavior and the structure. Let's look at them, very briefly. The functional classification is the easiest to use and understand, and often in practice, rules can be assigned with a single subject. So if you're working in a medical domain, you could say this set of rules, okay, or this rule applies to medical diagnosis. The other could be, let's say, surgical kind of thing. Okay, so that's the functional classification based on a single subject. And that often remains the default classification scheme for rules. The other is the behavioral classification, okay, of rules. That can be a bit more complex and is mostly encountered in the implementation and debugging of the rules rather than their specification. Okay, so when you're trying to run a system and understand what's happening, like debugging a typical program, that's where you need that classification. And so behavioral classification and rule behavior in general can be very complex, of course, remember that. And it can arise either from interactions between rules or between the values of data, being set to test the conditions within a rule. Okay, the third type is the structural classification of the rules, has the advantage of classifying rules precisely and unambiguously. However, the structural classification of a rule will not describe the important aspects of that rule, unlike functional classification. So, very briefly, what we have done is we looked at uh, rule-based systems, expert systems, production systems, the applications of rules, how they work, and the classification, very brief about the classification, how we can break down the rules. I hope you found it interesting, and we'll see you next time. Thank you very much.